The coherent state is a minimum uncertainty state. So it means that we have to show that the uncertainty in position and uncertainty in momentum and position, this must be equal to h cut divided by 2. So this is a question, and now we are trying to solve this question by considering the annihilation operator and the momentum and position operator. So the relation between the annihilation operator and the momentum and position operator, as this is a well-known equation, and A which is equal to this and A dagger which is equal to this. From these two equations we can find the value of Q as well as the value of P. First, if we subtract these two equations, then we can get the value of Q. Because if the value of Q is here, I think this is minus. Here, if we subtract these two equations, then this Q and this can be cancelled out and we can get the value of P. And if we add these two equations, then we can get the value of Q, which is equal to this. Now the point is, to solve this equation, we have the answer to find, initially to find the value of delta P. And for delta P, the expression is delta P square, which is equal to P square average minus P average whole square. So this is the main definition and main equation for this problem. And first of all, we must looking for P average and then square and then P square, and after this we can take the average. So let first consider P average, which is equal to, it means that P as this one, so average of A and average of this, and you must know about the average of annihilation operator and the average of creation operator of the coherent state. If we take the coherent state, this must be equal to alpha, and for this the average is equal to alpha star. So the average of this is equal to alpha and the average of A dagger is equal to alpha star. Now take the square, because we need the square. If we take the square, we have this, and alpha square plus alpha star square minus 2 alpha star. And then we have 2 and minus iota square minus. So we have h cut nu divided by 2, and we have this expression. Take p square first. So if we take the p square, then we have 2h cut divided by 4 iota square, and we have a square plus a dagger square minus a dagger a minus a dagger. So this is p square, and then take the average. So if we take the average, so this and this can be cancelled out. We have minus h cut nu, I think, here. Maybe this some missing here. This is h cut nu, and h cut nu divided by 2, and the average of this plus the average of a dagger square minus the average of this minus the average of a dagger. Now we know the average of A is equal to alpha, then the average of A square must be alpha square, and the average of A dagger square must be alpha star square. So this is nothing but this is very easy. But before doing this, we must convert this a dagger a to this, because if you we know as we know that a dagger, the commutation of this is equal to 1, then a dagger minus a dagger a, which is equal to 1, then a dagger, which is equal to 1 plus a dagger a. So if we replace the value of a dagger, which is equal to this thing, then it will be very easy. So you can take the value of this average alpha square and this alpha star square minus a dagger a, and we can put the value of this a dagger is equal to 1 plus a dagger a, and then we must apply the coherent state. This we have done some, okay, it's okay, it's okay. So minus h cut nu divided by 2 alpha square alpha star square, and from here we can get alpha star and alpha, and from here we have 1, and from here we must have alpha star and alpha, but yes, it's okay. And then further this will be equal to minus h cut nu divided by 2 and alpha square alpha star square minus 2 alpha star alpha minus 1. So this is the final the result. And now putting the value of this and the value of this in equation number 1. Now equation 1 implies that delta p square, which is equal to the value of this is equal to minus h cut nu divided by 2 and alpha square plus alpha star square minus 2 alpha star alpha minus 1 and minus, and we have another minus of h cut nu divided by 2, and the same thing we have the value of this we have already calculated, alpha square alpha star square minus 2 alpha star alpha. And now you can see here minus h cut divided by 2 alpha square and plus h cut divided by 2 alpha. So this can be cancelled out with this can be cancelled out with this, and this can be cancelled out with this. And only we have one value which is equal to h cut divided h cut nu divided by 2, and this have we have, if we finally calculate this, we have h cut nu divided by 2, and this is delta p square. And similarly we can find out delta q whole square by using the relation q square minus q average square. Using the same process, first you should find out the average of q and then take the square, and then q square and then take the average, and then you can find out delta q very easily. This is not so difficult, and then you have the value of h cut divided by 2 nu. This is square, and then delta p, this is delta p square, then we have delta p is equal to h cut nu divided by 2 under root, and this is delta q square, then delta q will be equal to h cut divided by 2 nu this. And then if we multiply delta p and delta q, then we must have h cut nu divided by 2 and 2 h cut divided by 2 nu under root. And here nu can be cancelled out, and we have h cut square, so we have h cut and 2, so this is equal to delta q delta p, which is equal to h cut divided by 2. So there is a minimum uncertainty and coherent state.